expressing a number as a product of prime factors. Now, this is one of the fundamental things within mathematics, is that every single number can be expressed as a number as a product of prime factors. So every single number that you can think of, and all the ones that you can't think of as well, provided they're whole numbers, you can always multiply it by a number of primes. It might just be one, so if the number's prime like 19, it can only be written as 19. But every other number can be written as a product of prime. So 2 squared times 3 times 5 cubed times 7 and so on. So that's what we're trying to do here. So the first thing that we need to do is to consider the first few prime numbers. So we're thinking about 2, 3, 5, 7, 11, 13 and so on. Then start with the smallest prime number, so that's 2. Divide the number if it goes into it. And you keep going until it won't divide evenly anymore. So you start off with a number, divide it with 2. If the answer is divisible by 2, go again. If that's divisible by 2, go again. And you keep going until it's not. So you don't jump back and forward. You exhaust the 2 until the number is no longer divisible by 2. Then you move on to the next number. So let's say you go to 3 and you keep dividing 3 by 3. Once it's no longer divisible by 3, then you go to 5. If it is divisible by 5, keep going with 5. If not, jump to 7 or 11. So you will always end up with a prime number. And what you should do is you should divide it by that to get 1. So list all the numbers that you divide it by and your final answer, and then put the multiplication sign between them and then group them into index form. So we'll look at an example of what we actually mean. So express 6,930 as a product of prime. So 6930. And the first step we need to do is we need to write out the first few primes. So 2, 3, 5, 7, 11, 13 and so on. This is sometimes known as the ladder method because it kind of looks a bit like a ladder. So we do our divisions. And we do our divisions underneath so that we can divide the new answer by a prime number. So we see how many 2's go into the number 6,930. So 2 goes into 6 3 times. 2 goes into 9 4 times with 1 left over. 2 goes into 13 6 times with 1 left over. And 2 goes into 10 5 times. Now this number is ending in 5, which means it's no longer divisible by 2, so we've exhausted all the 2's. We then try 3. So to see if a number is divisible by 3, we check the digit sum. So 3 plus 4 is 7. 7 plus 6 is 13. 13 plus 5 is 18. So yes, the number should be divisible by 3. So 3 divided by 3 is 1. 4 divided by 3 is 1 with 1 left over. 3 divided into 16 goes 5 with 1 left over. And 15 divided by 3 is 5. Let's see if the number 1155 is divisible by 3. So 5 and 5 is 10 and 1's 11 and 1's 12. So yep, it is. So let's go again. 3 into 1 doesn't go. So put down a 0, carry a 1. 3 into 11 goes 3 times, remainder 2. 3 into 25 goes 8, remainder 1, and 3 into 15 goes 5. Let's see about 385. So 3 and 8 is 11. 11 plus 5 is 16. 16 is not, so we've exhausted our 3's. So then we need to go to 5. Let's divide 385 by 5. So 5 into 3 doesn't go, so 0 and carry 3. 5 into 38 goes 7 times with 3 left over, and 5 into 35 goes 7 times. So we've got 77. Now 77 ends in a 7, so that means it's not going to be divisible by 5 anymore. So we try 7, and 77 is divisible by 7. 7 goes into 7 once, 7 goes into 7 once, so we're left with 11. And 11 is divisible by 11 to give 1. And we've ended off with 1. So what we have is 6,930 is equal to 2 times 3 times 3 times 5 times 7 times 11, which we could write in index form as 2 times 3 squared, because there's two 3's being multiplied together, times 5 times 7 times 11. Example 9 express 462 as a product of prime factors. So first thing we'll do is write out some prime. So 2, 3, 5, 7, 11, 13, and so on. 462, we'll get our ladder drawn and we start with 2. So is 462 divisible by 2? Yes, because the number at the end is even. So 4 divided by 2 goes twice. 6 divided by 2 is 3. 2 divided by 2 is 1. Now we can see that the number is no longer even, so we've exhausted our 2's. So let's try for 3. So the digit sum, 2 plus 3 plus 1 is 6, so it's divisible by 3. So 3 into 2 doesn't go. 3 into 23 is 7, remainder 2. 3 into 21 goes 7. 77 is not divisible by 3 because 7 plus 7 is 14, so we've exhausted 3. It doesn't end in a 5 or 0, so it's not going to be divisible by 5. So 7, let's try 7. 77 divided by 7 goes 11 times. It's no longer divisible by 7, so we can divide by 11 to get 1. So we've reached the magic number of 1 at the end. So now 462 is equal to 2 by 3 by 7 by 11.